Hello everyone, thank you very much for joining me again for this event where we discuss the persistent layer of a Java application, a very important subject because in most cases your Java applications have a persistent solution. So we talk about many applications that are used on the server side, and usually we need a way to store and manage our stored data, and that's where the persistent layer comes. And we're going to discuss this today. It's a more theoretical discussion, and to make it more interactive, remember please that you have a live chat there. So if you are here with me watching this live, you can start discussions and ask the questions in the live chat and say hello, of course. Thank you very much. So I see already a few people have connected, and let's make this discussion as much as we can. And I want to discuss about the possibilities you have to design the persistence layer of your Java application, and then how we choose this persistent layer and the technologies from the variety of technologies that we have, because we have so many nowadays that you don't necessarily know what to choose, and many people tend to default to some technologies that seem to be more advertised, like for example JPA implementations like Hibernate. And we use now, like if you have a Spring application, you do use Spring Data JPA as a default. I've seen that in many projects and in many cases, even though in some cases, maybe in many cases, that wouldn't be the right solution. So let's try to first figure out where we are and what the persistent layer of an application is, and then we will try to consider the technologies that we have today. I will be a bit biased and I will discuss about Spring as a framework because in many cases we do use Spring, and also because I'm a Spring guy in general. So let's try to understand. So we are here now. We have a database. Oh, sorry for that. So we have a database now, and this database is used by our application, which is this rectangle here. So in case you have some functionality, you do design usually a specific part, module, I would call it layer on your application that deals with persistence. So you do delegate whatever from this application to this persistence layer here, and the persistent layer has the responsibility of dealing with the communication to the database, whatever database it is. So in this case, we can talk about both SQL and NoSQL approaches, because we don't really care now whether you choose a SQL or a NoSQL. Depends on the use case, on the business case that you implement, and that's based on that you then decide what the technologies you can use on the persistence layer. But when you choose something like NoSQL, whether it's Redis or it's GraphQL or it's Neo4j, what else? GraphQL. Sorry, I meant Neo4j and I end up with GraphQL in my mind. Whether it's Neo4j, whether it's Cassandra, whether it's Mongo, Cosmos, there are so many varieties. And when you choose one of the approaches, however, on a NoSQL approach, usually you have one choice to make it low level, and another choice, for example, if you work with Spring, to make it more abstract, which comes with the Spring data package of technologies. But when you approach a SQL database, then you do have different ways, and the two main different ways that you have when talking about SQL are either using directly a JDBC, not necessarily JDBC vanilla. So not necessarily, when I'm saying JDBC here, I don't necessarily say you start working with prepared statement, results set, and so on. So you never, no one actually forces you to straightly use the JDK interfaces and classes. You can now use JDBC more in a more abstract way, like for example with Spring Data JDBC. So when I talk here about JDBC, I don't say that you should actually, you shouldn't, no, you shouldn't go with the vanilla JDBC, because that would be an act of cruelness. No, you would be having to write like tens of lines, of dozens of lines of code just to insert something in your database or select something from your database. And of course, let's remember that we would have to actually also treat the SQL exception, which is a checked exception. You usually don't know how to treat that SQL exception, and so on and so forth. So using a framework such as Spring, for example, gives you a little bit of more abstraction and helps you step over this boilerplate code that you would have to write whatever operation you do with JDBC. And then of course the other opportunity is using something like an ORM framework, and here we have the JPA implementations, for example, such as Hibernate, as being in the Java ecosystem some of the most encountered frameworks. And then the question is, when do we choose what? Because in my experience, and now I'm creating this video mostly to answer the question I got multiple times from some of the subscribers here or the followers on Twitter and LinkedIn, which is, when do I choose to use, for example, JPA? And for me, the question, being a very good one, it's also not a complete one, because the question for me would be not when do we use JPA, but what technologies can we use to implement our persistence layer in our application, and when to use one and when to use another. And the point is that you have to keep in mind that there is no technology, whenever and whatever, that is a silver bullet and applies to all the cases. And this rule applies also to JPA. So this is an excellent approach in many cases, but it's not an excellent approach in all the cases. And I will even tell you that I see a large number of applications that would actually benefit from using JDBC. And today we discuss the differences between JDBC and ORM, and let's, for the sake of the discussion, assume that we have the advantage of the simplicity of using Spring Data. Because if you use Spring Data, then you can choose to use either Spring Data JPA or choose Spring Data JDBC. And then, regardless on what you choose, you will anyway have a very similar abstraction layer, because with Spring Data, what you do is simply writing an interface. And then, depending on what you chose, if you chose a JPA, the Spring Data JPA, that will come behind the scenes with the JPA implementation. So then you will be able to use something like, for example, the entities. You have to define your entities, your JPA entities, and then you will basically work on an ORM methodology, thinking everything is object and everything that you do, every operation is based on an object context, which happens behind the scenes because of the JPA implementation you configured, or Spring Boot configured in your application. If it's Spring Boot, then by default you will have Hibernate. But if you chose JDBC, then you have the freedom of designing your DTOs, whatever you'd like, and then possibly you'd like to, for example, use records because you maybe want to use an immutability pattern in your application. but you will still only have to write an interface, and then you will be able to write native queries. So let's see which are the characteristics of one or the other, and why would I choose one or the other. So remember, I already see a lot of messages in the chat, and I'm saying hey to everyone. Thank you very much for being here with me. You can ask your questions. So I already have a question. No, what is the difference between Spring Data JPA versus Hibernate versus JDBC versus Java Persistence API? Wow, what a question. So I think that's actually an excellent question, because it doesn't even make sense to go further with our discussion if we don't first understand properly all these terms. No, so let's take them one by one from Raul and understand from Raul's question and understand which are the differences between these. So let me start with JDBC, because maybe it makes sense. No, JDBC is the most low level out of all these acronyms, terms that we have been using and we will be using throughout this video. So this is Java database connectivity. No, Java database connectivity. Okay, forgive my ugly writing. I'm not really used to handwriting anymore. But JDBC, which is the low-level approach, this is coming directly with the JDK. So the JDK plus, and this is important, you always, in the design of Java apps connecting to a database, you always need a driver, which always will be an external dependency. The reason for that is because in the JDK, you only have abstractions. These abstractions are designed to be usable regardless of the technology that you choose for your database. Because here you can choose MySQL, you can choose Oracle, you can choose Postgres, you can choose a large variety of technologies now. So that's why what you have here, the abstractions, they always need a proper implementation. The proper implementation for connecting to that specific technology that you have chosen. And that's why in a Java application, regardless of what kind of persistence layer you choose, you will always have this external dependency named driver that comes with the implementations for that specific technology you've chosen for your database management system. Okay, so when we talk about JDBC, I'm talking about being able to directly send SQL queries to the database. So your Java application has some SQL queries, usually defined as strings, straight through the driver, sends them to the database management system. Okay, so that's possible, first of all, to do it directly with the JDK if you use those classes like prepare classes and interfaces types like prepare statement, result set, and so on and so connection and so on and so forth. So everything that comes in the Java SQL package here in the JDK. And then what you don't want to do is you do not want to use this JDK directly. We would have done that like 25 years ago. But if you use that now, you have to write a lot of code for very simple operations, such as just the simplest select query, for example, would require you to write a very uncomfortable large block of code. So that's why framework nowadays, they tried to, as much as possible, help you write less code by eliminating all the common code that you would anyway write just to be there, but you could actually avoid seeing it. And then one of the first, if we talk about Spring, one of the first approaches to help you avoid boilerplate code was the so-called JDBC template. Now, depending on how old you are and how much experience you have, you might have actually used the Spring JDBC template, which was a great tool. Spring in general came with these template types, when you hear the word template in Spring terminology, is usually a util class that helps you do something easier. That's why, for example, you have a JDBC template, but you also had a REST template, for example, that was usable for making life easier with REST calls. JDBC template, as the name suggests, it eliminates some boilerplate code, so such that you would actually only have to write like 20% of the amount of code that you would have written if you would have used the JDK approach, which minimizes a lot the effort that the developer would put into writing their persistence solutions. And then, of course, things evolved, and we usually do not use the JDBC template anymore today in applications, or at least not in newer applications, because we do have Spring Data. And Spring Data is a project which is part of the Spring family, of course, but what you do have to remember about Spring Data, it's one of the mistakes that people do when thinking about Spring Data, is that they tend to believe that Spring Data is one project, or it's maybe you can consider it one project, but the point is that there is not one dependency and not only one focus of this project called Spring Data. There are like 20 Spring Datas, and if you are going to either the initializer on Start Spring IO, or you try to create a project with an IDE, for example, Spring Boot, for example, and I'm just going to go next. I'm not creating the project, I'm just showing you what Spring Data is here, and I'm searching for Spring Data. You will actually see that Spring Data is a large number, I didn't count them now, but it's a large number of dependencies. So Spring Data, it's a project, but it has multiple focuses and not only one dependency. And if you, for example, want to choose a NoSQL technology, see they are here for me split it into SQL and NoSQL approaches, you can choose to use Spring Data for Redis, for Mongo, for Elasticsearch, Cassandra, Couchbase, and so on and so forth. But even if you have chosen a SQL approach, you still have two possibilities. I'm skipping the third one because this is the reactive approach, and I don't want to go into that. We can also use name parameter JDBC. Yeah, true. So that there are multiple tools that you can use. Now, usually the templates, the templates for using SQL, they are no longer used because, well, whoever ever used Spring Data, you know that there is nothing at the moment better than Spring Data for implementing your persistence layer. Now the question is, what do you choose? Do you choose to use Spring Data JDBC or Spring Data JPA, for example? And now going back to my explanation, so when I can choose to use JDBC template, I can use the named parameter JDBC template suggested here by Adama, for example, in the chat, thank you very much, or any kind of tool like that, or you can use Spring Data. And remember, Spring Data is not necessarily JPA. You have the Spring Data JDBC, which allows you work with a JDBC approach, but a Spring Data abstraction, which makes things incredibly easy, because the only thing you need to write with the Spring Data JDBC is you do exactly what you do with the Spring Data JPA. If you use that, you have just to write an interface. And you write an interface, and you write the methods, and you can use the naming conventions for the methods, which, by the way, I never recommend it, but you can as well use the query annotation. And in the query annotation, and of course, let's assume I'm using text blocks because I'm upgrading my application always, you can use the select everything from whatever. So this is a native SQL. Because I'm using Spring Data JDBC and I can use it with native queries, and I do not have to think in the NoRM technology, in an ORM methodology. I do not have to think about the context because there is no context. I'm just sending queries the same I would do them with JDBC template, name parameters template, or simply if I'm working on a very old application, the JDK directly with that large block of code. Just that instead of having to write a large amount of code, I would have to only define an interface and everything is coming as magic behind the scenes. Now, going back to Raul's question, no, so the JDBC, I hope it's clear now, and the tools helping the JDBC, no, but then we also use terms such as JPA, you know, it says what JPA is. And this is, and I do recommend you, now I'm going to be short now because the plan is not to keep you like forever here. It's just a video, and I know I'm always keeping them as short as possible because I know you're getting bored then, and I don't want that. I just want you to stay with something after our discussion. But I do recommend you go into my playlist about JPA and Hibernate, and you will find out a lot of more details there because there are like dozens of hours there of discussions and examples, code examples and everything about JPA and Hibernate. But JPA, what I want you to remember in case this is the first time you hear the acronym, is this is the Java Persistence API, or whatever, Jakarta Persistence API, doesn't really matter now how we name it, but this is a specification. So this is not a given implementation. It tells you how some mechanism should work, but it doesn't implement the way it works. So it gives you some contracts, it gives you some interfaces, and it describes very roughly, if you will search on the internet like JPA specification PDF, you will find a large PDF about 700 pages. You can read it in detail, and this is the specification informing how any of its implementations should work, but also being the contract that someone using such an implementation would know what to expect when they are using that. So me as a user of a JPA implementation, I know that always the implementation should respect the specifications, should fulfill the contract in the specification. So if the specification says that when I'm using a specific operation such as persist on a specific entity in a specific case, this is the way it should work, the implementation should do that. And if it doesn't do that, then it's a bug in the implementation, which rarely happens. No, it gives you the comfort of having this contract. And then an implementation such as Hibernate now gives the implementation. And when I'm using in my application, I say I'm using something, I'm actually implementing it using the implementation. So I need an implementation. Hibernate is one of the choices and the most known of the choices, but there are others such as ORM Lite or Eclipse Link. So whenever someone says that they are using JPA, they actually mean they are using a JPA implementation, because the specification would only be a specification and not something that really works. No, it's just a contract telling you how the implementation should work. So now, the other possibility is that I'm using an ORM approach. And in this case, say I'm using JPA. And then I'm going to put here JOOQ just to remember, because this is also another possibility. Okay, but let's talk about the most encountered first. So when I'm deciding to use, for example, JPA or JPA implementation to be more specific, then I do have the choice to straightly use Hibernate, or I do have the choice to go a little bit more abstract and use, for example, if I'm using a Spring application, Spring Data JPA. Okay, so normally, if I would be like 15 years ago, I would probably directly use Hibernate in my application, and here you might have heard about classes like Session Factory. Or if you are using it through the JPA specification, Entity Manager Factory. Okay, and using them directly, then I would have to manage the transactions myself, manage the context. I would use methods such as persist, merge, find. I would have to use create query or create a native query to create different kinds of queries on my choice. And I would end up with code that, again, is a little bit more than I necessarily need. Or I can use the Spring Data JPA, which does the exactly same thing Spring Data JDBC does. It allows me to use a simple interface definition to define my methods, but in this case, when I'm writing the query, then I would have to write a JPQL query. No, I would have to write something like select P from, say, product P. No, this is a JPQL. No, I'm selecting, and behind the scenes. Now, if I'm using, let's say this is Spring Data JDBC, and this is Spring Data JPA. No, this is my application, meaning the business implementations, and then this is Spring Data, which uses directly the JDK and the driver to reach the database. While in case of Spring Data JPA, I have the application, my application with the business implementations. Then I have the abstractions coming through Spring Data JPA. I would have the implementation behind the scenes, like Hibernate, for example, which further uses the JDK and the driver to connect to the database. And here is where you have all the part with the context, and everything that the JPA specification describes. So this stack, you see, this is a lot simpler because this is only an abstraction allowing you to use interfaces directly in the simplest way, to use the JDK to send native queries to your database. So that's why here, when you go with the query, you have a select star from, which select projection. This is the projection in a normal native query. While here, when you use the Spring Data JPA, then you use actually the abstractions, but then you have the Hibernate. Hibernate has a context, works exactly as the JPA specification states, mandates. You have to think in terms of objects. You are no longer working with the database directly. You are working with a context. You need to know the operations of the entity manager, persist, merge, and so on and so forth. And then Hibernate will take care on the definition to send the queries, and then through the JDK to the database. No, So this is the difference between using Spring Data JDBC and using Spring Data JPA. And then that's where I want, did I miss anything? So it's a difference between Spring Data JPA, Hibernate, JDBC, Java Persistence API. So I covered all this terminology now and one by one for the question. So I think we are done now with that, and hopefully that is clear. But please do let me know in the chat if there is anything that that's not clear. And of course, remember, if you are not watching the event live, if you see the recording, you can still put your questions and comments in the comment section, and I'm trying to take care of them as frequently as I can. So now the question is, I have my choices. Now, if I'm using SQL, which is the most interesting part, am I using JDBC directly? Am I choosing to use Spring template or the name parameter JDBC template? Am I choosing to use Spring Data JDBC? Am I choosing to use Hibernate directly? Am I choosing to use Spring Data JPA? So which is the choice I should take for my application? So what is my choice? JDBC, plain JDBC? Clearly not. There is no reason you would use now vanilla JDBC. Let's call it vanilla JDBC. So my opinion is that you have no advantage. Now, if I am to choose between like something like a template or Spring Data JDBC, this basically really depends on what exactly you choose, no? Because maybe your application is not a Spring one, and then you choose a given template for whatever your application or your framework offers. Or maybe you do have an older Spring application, and then you do choose to use a template. Okay, so it would be, both of them would be fine to use with JDBC. And the same here in Hibernate. So do I choose ORM vanilla, or do I choose to use the Spring Data JPA? And now, of course, if I'm in a position where I can use Spring Data, then definitely I'm using Spring Data. So put a big check here and here. So I'm using either Spring Data JDBC or Spring Data JPA. And of course, if I'm not in a position to do that, then definitely I would still choose to use one or the other, but I would tend to avoid the boilerplate code coming with JDBC. This is the first thing you learn when you learn Java. It's good that you learn it. It's always necessary to know those statement, prepare statement, result set, and so on, because that's behind the scenes, but never do use it straight in your application. It makes no sense. Okay, I see a little bit more questions here, so I'm gonna take a break and try to use them. Okay, for JDBC and MongoDB implements, signature will be different for JPA. I'm not sure if I understand if that's a question or not. Please do rephrase it if you can rephrase it, because I really don't understand if it's a question or a statement and what the question or the statement is. And then I use Spring Data JPA. That's good, maybe, or maybe not. So that's my question. Is when it's a good practice to use, for example, let's make it simple just for us, okay? Because I think we did understand like the difference between these two and these two. Now the question is, say we are in the fortunate situation where you can use Spring Data JDBC or Spring Data JPA, and the question is, which one do you use? Let's say Spring Data JDBC versus Spring Data JPA. Who's winning here when? And of course, to understand, to give an answer to this, we need to understand JDBC. We need to understand first, okay, what are the advantages and disadvantages. So let's put them again in a balance here and say this is, I'm using Spring Data JDBC, or I'm using Spring Data JPA. No. And then what do you gain? So which are the advantages and which are the disadvantages? Maybe we can even split it like that, no? And say advantages, disadvantages, advantages, disadvantages. So for Spring Data JDBC, the advantage would definitely be simplicity. Even if I'm going back here to my diagram, you see that the application is simpler. It only gives you the chance to send queries. There is no JPQL, no context, no nothing in terms of methodology. And also the footprint of the application is definitely smaller because you end up missing completely a huge dependency. So you can say here that the footprint of the application is also an advantage. No? Meaning how large your application is, which might be important, might make a lot of sense if your application is running in cloud, might make sense if you use a Lambda running application and so on and so forth. Okay. What else is the JDBC advantage? So definitely you use more low level. So being more low level, you have the opportunity to use on the queries many things to optimize your application. So the fact that it is low level and offers you, how do I say that? So offers you more options, no? So more options to define and optimize the queries. Okay. Now you can hear my birds. I only have one, but it's sometimes crazy enough. So only one, it's enough. It's a parrot. At some point maybe I'll put it on social media. Sorry for that. I have no chance of making it stop or be more quiet. So I still hope that you can hear me better than my parrot. Then so the simplicity, footprint, more options, no, because you write the native queries, so you have the advantage of writing exactly the indexes on the queries. You write the query exactly as should be for your database. Then the disadvantage, one of the disadvantages could definitely be the fact that you become dependent on the technology. So now you write on native queries, they are for specific technologies. So say we are technology dependent here. Okay, so one of the things that JPA comes with is the transparency over the technology that you use for your database management system. So it's transparent to the technology, to the DBMS technology. This can be an advantage, or it might not necessarily be an advantage. It depends. I'm not sure if I'd ask you how many times have you seen a project changing their their SQL technology, say changing from Oracle to Postgres, or from MySQL to Postgres, or from Oracle to Postgres. Have you seen this happening often? I have seen that a couple of times at least, but a couple of times for me is not that often, because I do see a lot of projects, and it rarely happens that this kind of technology is changed. So what I would say is, I would never choose JPA thinking like I'm choosing JPA because maybe somewhere in the future I have to change the technology. Okay, I wouldn't take this, I take it as an advantage, but I would not take it as an essential point for choosing JPA over JDBC. But one of the other advantages that JPA offers is that it has embedded some mechanisms for caching the container itself, management over the entities and relationships. So you can define, you start actually by defining the entities and the relationships among these entities, and then you can decide how these are fetched, when are they fetched, if they are cached, and all the mechanism comes out of the box. But also this comes with a disadvantage, which is the complexity. So sometimes I would say that JPA is so complex that even experts who are very experienced with JPA might make mistakes. I have used JPA for a long time in many projects, and I'm still facing myself making mistakes. And that's because, and maybe I'm also guilty sometimes, but it's also because the JPA implementations are complex. So when you choose one or the other, as an architect now, I'm giving you the advice as a perspective, from the perspective of an architect, I would choose the simplest solution that solves my needs. So in many cases, it's not needed to have the complexity of an ORM that comes with the learning curve for the team, with the error-prone possibilities, the large amount of error-prone possibilities that you have there, unless the application is large enough for it to make sense to not have me recreating capabilities that come directly through the ORM dependency. But if my application is small enough and doesn't necessarily need the optimizations provided by the mechanisms of a JPA implementation, and the only thing I need is to just send some queries, grab some data, work with it, the more simple approach will always be better. So that is the JDBC approach. And if you take them, because now having Spring Data, JDBC and JPA, they look very similar in terms of the way you write the code. So I will not do it today, but I have already examples in, I think, my Spring playlist or my Hibernate playlist, and you can see me writing there code that uses either Spring Data, JDBC or JPA. But the point is very similar. So if in the past, when we were discussing using JDBC versus Hibernate, for example, having no Spring Data at all, one of the advantages and one of the points would be, yes, but with Hibernate you do usually end up writing less code, which was true normally. The point is now you don't have that anymore to defend the JPA, because with Spring Data, as an abstraction layer, going back again to the diagram. So basically this layer here, this layer makes everything look the same, almost the same, regardless you are using JPA or JDBC. So imagine it's almost the same thing. The only difference is that with JDBC you will always write native queries. With JPA you will almost always write JPQLs, and you can write native queries, but it's exceptions. So normally it looks the same. You write an interface, the methods, you write the queries over the methods, you use them. So now the amount of code is the same because of this layer of abstraction. So when you decide what to use, you don't decide what to use anymore based on how much code you have to write, because that would be the same. You decide based on the simplicity. Does it make sense for my application to have my team learn all the complexities behind the scenes and add additional checking steps, such as, for example, I always recommend people developers who use Hibernate to have some profiling done at the end of their implementation or bug fixing, because, well, you might introduce n+1 queries, you might introduce unnecessary updates. I also have some videos about that. Sorry for that. So do check them out. If I do choose the complexity of Spring Data JPA and the JPA implementation, I choose it because it makes sense, because it saves me time, because I need caching, because I need the relationships defined for fetching, because I need the optimizations that Hibernate might offer, and then it makes sense for me to add to the footprint of the application and to add the complexity of the coding and to add more time for testing, but in the end the application will be better. But now do think and ask yourself, and with this I will basically end up my discussion for today. I want you to make an exercise and think about this and ask yourself the question: in my application, after we discussed this and you found out maybe and hopefully some things, does it make sense for me to use Spring Data JPA, or would it make more sense to use Spring Data JDBC? And I wouldn't be surprised if some of you would actually discover that Spring Data JDBC would offer them more advantages, because again, in many cases I have seen applications choosing Spring Data JPA just as a default, and in many cases I have seen developers making a confusion, understanding that Spring Data is only Spring Data JPA. With that, I'm closing here. Many thanks everyone. I'm waving goodbye. I hope this was another excellent video and you've learned a lot of things, and I hope to see you soon in other events. Cheers everyone.